Hello everyone, my name is Jared Hogue and ENME 373 Computer Aided Design. Our final project was to choose an object and completely uh, create it in Solidworks. So what I did was I created my motorcycle lift. Here's an image of what it does. Right now it just looks like some goofy little machine. So all it does is it allows you to lift a motorcycle up to 1,500 pounds safely, jack it down. It's got tie down points on it. All it is a bottle jack with some control arms that we'll get into. Um, Makes it really nice when you use a little stool like this. You can navigate around it. You can look under it without getting down on the ground. So let's get into the drawing. Let's start with the little animation. Since some of you probably don't want to sit through and watch all of the little nitty-gritty parts, what I did was I put two motors on this. I wanted to get the visual of how you actuate it, which is this foot lever. This foot lever, you pump it, it actuates the ram on this bottle jack, pushing up on this control arm, and then pulling these with it. So I had to insert a motor. I put it on this pin here. There it is. It is a rotary motor. I've also put another rotary motor. That one I use in oscillation because I want this, as this raises, because it would require a lot of pumps, I want it to go up and down. I don't want it to just pull down slowly as this goes up. The second one was a little bit easier. This is just a constant rotary motor. I wanted it to go up over a course of 10 seconds from its lowest point to its highest point. So now let's watch how it happens. It's a little laggy because my computer is definitely not made for all of this stuff going on. You can see it's supposed to pump the whole time. Sometimes it does, sometimes it doesn't. You see it pumping, pumping. The lift slowly rises. And that's probably the coolest part about my project, was that it is still dynamic. Everything's fully constrained. Well, I guess it is still technically under constrained, but nothing is able to pull through. Nothing collides with itself. Nothing is I'm lying about that. The one thing that I was not able to constrain properly because it would require functions for its path is these safety arms. These safety arms, they might have to go to model mode to show you. I did not put any angle limiter on these. All I did was make these concentric with the bolts that they sit on, and I made them coincident with the washers that space them. The issue is that they will still go through each other. What's supposed to happen is it's supposed to ride along this track and then get stuck here so that if the jack fails, it'll catch itself. But besides that, we have angle limiters on the upper. This is your upper control arm and this is your lower control arm. They will not run into each other. I used the move component collision detection and then put an angle limiter on it to set a lower limit so that doesn't collide. And then you have this extra piece of tube steel on the upper, and you don't want it to go so high. In the real world, when you pump it up so high, this piece of tube steel is going to run into this. And I did the same thing with the move component and collision detection so that it would not hit. It'll go right up to it, and there it is. Just to show you that it's not going to go past it, we'll keep dragging it and nothing. But there it is. You see the bottle jack is, so this is your primary ram. This is the piston that is driven when you pump the foot lever. This is your ram extender. So when it's in its lowest mode, when the lift is as low as it can go, you can see it's threaded so you can raise and lower this. These two are on an angle limiter because I didn't want this cylinder, this ram extender, to come out of the bottle jack, because in real life you obviously wouldn't want that. Now the hardest constraint that I had on this project was to get that ram extender to stay within this pocket. And it's hard to see right now. Let's hide this component so you can see what it is. It basically looks like a bolt, a threaded bolt that is threaded from the top to the bottom. Now I wanted that to stay within Where's my control arm? We put the control arm back in. As you may have just noticed, this kind of hides itself in there. It was the only way I was able to constrain it. I had to use a tangent constraint with this face and the jack control arm. So let's find that real quick. Make it visible. Let's see. It's hard to tell, but in order to get this control arm to stay above that and still, because as you raise and lower it, you'll notice that it changes angle. This control arm changes from, it swivels sort of like this with the top of the ram extender as its pivot point. So that was a super difficult, it took me many days to figure out the constraint to use that. Some other stuff with it is I had to create swivel brackets for my front swivel wheels. I also had to create new caster wheels. Earlier in the semester we created caster wheels. The cool thing about mine is that it will still swivel. The one different thing about the caster wheels from the ones we created previously in the course is mine has, let's see if I have a drawing of it. The caster wheel we originally created only had a shaft in the middle and it just rode on the shaft, and that's fine if it's something light, something that is not going to wear and tear on it. But this piece of equipment is about 130 pounds because it's all steel. So I had to put in a roller bearing. Let's go to the drawing actually. You might be out here. Caster wheel drawing, perfect. So there's the exploded view of it. This is the shaft that most caster wheels will have if it's a lighter weight object, but this one has roller bearings that ride on that shaft, and then these roller bearings roll on the caster wheel. There it is. I had to create one roller and one end of it, this piece, and then I was just able to make an assembly. Let's go back. Oh, so we also have little explosive view so you can see how this swivel wheel was kind of created. So another special thing is this bolt. You see that funny little thing at the end, that's a grease fitting. That's so because of how heavy this is, you want every single dynamic piece to be greased well, because otherwise it'll just wear and tear. And you can see it's on every single piece it's going to move. These are a 3/4 inch bolt. I was able to find these on McMaster Car. I had to add the grease fitting in myself. You may be able to see it. Yeah, so you pump grease into this grease fitting. Let's let it come back out. Pause it. So you pump into the grease fitting. It pushes through a passageway here and then spreads out within this shaft. So as this wheel's spinning, grease will spread itself all over this smooth face. Let's collapse that. One of the last very cool things about this project why is that not collapsed? There we go. One of the last really cool things that I thought, oh, also, you're probably wondering this whole time, what are these? What are these little, what is that? So I had to add, you can't see it, it's not, I took it off of my toolbar. These are weld simulations. It's the visual of a weld. So I put 3/16 welds on every single piece that would have been prefabricated if you were to do just the assembly, if you're not creating each piece from individual angle iron and tube steel. So if you had the base, that was how I created mine, was if you would receive the base in a package and the control arm in a package and angle irons and this, that, and the other. inserting the welds definitely put a strain on my system. Here's your little tie down points. They are stationary, unfortunately. But back to the cool thing. This is a decal, and that is the true decal. That's a picture of what is actually on the lift. That's the Millennium Engineering brand, Pitbull MC lifts. All you do for that is go to Appearances, and this is where you would normally go. Appearances, Decals. You can see I've already added them in, but if you wanted to add in, you could add in any photo to this. Add decal, and then you can choose from photos you've saved. And they will be stationary on the sketch plane that you have chosen. So that's my lift, guys. I hope you liked it. This definitely took a lot of time. As you can see, a ton of parts, mostly hardware, but in order to get each one to stay, as you can see right here, there is like a million constraints. So if you decide to open this up, you don't be surprised if it gives your system a little lag. But yeah, thanks for watching. I hope you liked it. Take care.